Hi, I'm Swarupa Sain, course instructor for fluid mechanics. In this presentation, we will go through conditions for stability of floating body. First one is stable condition, and the required condition is Bm should be greater than Bg. Here we can see an object. Let us say that this object is in water, and hence there will be force of buoyancy which will be exerted on the object at point B. W is the weight acting at point G and M is the metacenter. For stable condition, Bm should be greater than Bg. But Bm is sum of Bg and Gm. So, Bg plus Gm should be greater than Bg. And we can write that Gm, that is metacentric height, should be greater than 0. The value of Gm which we get from the equation to find metacentric height should be positive. And we say that the body is in stable condition if the value of Gm turns out to be positive. For unstable condition, the required condition is Bm should be less than Bg. Bm is sum of Bg and Gm, so Bg plus Gm should be less than Bg. And we can write Gm should be less than 0. When Gm is negative, the floating body is always in unstable condition. We need to find out metacentric height and check whether it is positive or negative. If it is positive, we say that the body is in stable condition, and if it turns out to be negative, we say that the body is in unstable condition. The floating bodies like ships and boats are acted by external forces like wind, wave, tide, or while shifting the cargo or passengers, which temporarily cause angular displacement. So, for the better stability of the floating body, the design should be done in such a way that the metacentric height Gm should be as high as possible. And this can be done by lowering the CG of the floating ships by adding heavy loads at the bottom of the ship, and such loads are referred to as ballast. Here we can see the ship, and this is the plan, and it is enclosed in a rectangle. To find Iyy, that is moment of inertia about yy axis for this ship, we use the equation Iyy for the rectangle, which is shown in yellow color, into C. C is the correction factor for the shape generally used for the ship. And Iyy is always considered for finding metacentric height, as possibility of dipping the ship about XX axis is very rare compared with rolling, that is tilting about YY axis. So we consider Iyy for the ship, not Ixx. Thank you.